I am recording now. All right. So last day we talked about naming cycloalkanes. If I can go back there. And I gave you a couple extra ones. Yeah, okay. So last day we talked about cycloalkanes and we did practice drawing them from their names. So today there's just a little bit extra and we're almost done chapter 2. There's a couple extra carbon branches I want to show you. So first of all, alkyl substituents. If you can recall, this is obviously just something I mentioned before. We looked at the homologous series. Now, if you can't remember what that word, we basically looked at the first 10 carbon groups in the series: methyl, ethyl, propyl, butyl, and beyond that, we probably won't see in this course. Like when you get to like pentyl and hexyl and heptyl, they get a little bit too long for this course. So, you know, you'll definitely see methyl, ethyl, you might see propyl, but there are special butyl substitutes that have common formats. And you guys actually saw one in lab number 2. You guys synthesized one of these. You made T-butyl chloride, which we never really talked about the shape or the molecular structure of that, so we will today. So again, this is just total recall. We've done this before. You know, 1 carbon is methane, 2 is ethane, 3 is propane, 4 is butane. But when they become branches on a carbon chain, we change them to, instead of like methane, we have methyl group. Ethane will become an ethyl group, and you guys know that. However, some of the branch substituents have isomers. So remember what isomers are. They have the same chemical formula, just a different shape. Propyl has, I think, 1 or 2 isomers, well, 2 isomers, and a butyl group has a couple more isomers, and they have common or prefixes that are commonly used today that unfortunately you guys are going to have to know: iso, sec, and tert, and they mean something. They each kind of have a meaning that I'll go through now today. This is a little bit more challenging than anything we've done so far, but I think with a bit of memorization, this is actually pretty easy. So let's start with propyl. Oh no, sorry, I got ahead of myself. First, I'm going to tell you what iso, sec, and tert mean, then I'll start with propyl. Getting ahead of myself, and there's a message in the chat there. Good morning, Niam. Okay, so let's look at in this course, you're only expected to know 3 of these types of isomers. So the first prefix is just iso, which is short for isomer. The prefix iso is commonly given to 2 methyl alkanes, and I'll show you what I mean by this in a couple. I have pictures of this or images of this for you guys a bit late, in like 3 or 4 slides. So if there's a methyl group located on the 2nd carbon of a carbon chain, we can use the prefix iso. The prefix is placed in front of the alkane name that will help indicate a total number of carbons. So something like, excuse me, isopentane. Isopentane is the same as 2-methylbutane. So you might see this in, you know, working on site or something like that. You might see different names like IUPAC or systematic. Systematically, you might call it a 2-methylbutane, but honestly, a lot of people, even IUPAC, you still use these prefixes like iso, sec, and tert. And again, if this is confusing, I do have pictures of this coming up. So isopentane, this means you have a branch with 5 carbons, okay, because it has pentane. But what that means is on the 2nd carbon, you have a methyl group, and then you have 4 in the chain. Isobutane, we would have 4 carbons. Okay, here we have 5, here we have 4. Well, that means on the second carbon, you have a methyl group and it's propane. So these are just isomers. And the word iso means it's an isomer of butane. The isomer is 2-methyl propane. Okay, again, this is a little bit weird. I will show you pictures in a minute. The only other 2 prefixes you need to know are sec and tert, which are shortened words for secondary and tertiary. If the carbon is attached to only one, and this will actually, sorry to interrupt, I just interrupted myself. We're going to look at this a lot more in Unit 6 when we deal with alcohols, because you can have primary, secondary, and tertiary, alcohols. So if a carbon is attached to only one other carbon, we would call that a primary carbon. So let me give you an example here. Oops. I don't know what just happened there, where my writing went. So for example, let me get a different color here. I'll use purple. This carbon right here at the end would be primary. And for primary, we use the number 1 with like a degree sign after it. This carbon, this purple one I'm pointing to, is only attached to one other carbon. Now, what about a secondary carbon? And you will need to know this for chapter 6. Well, let's look at this carbon in the middle. Oops. This carbon in the middle is a secondary carbon. Why? Because it's attached to other carbons. It's in the middle of the chain. It has a carbon on the left and it has a carbon on the right. So what about tertiary? Let's get another, well, I'll go red again. So in this situation, if you look at the very bottom of the slide, let's look at the carbon in the middle. This would be a tertiary carbon, meaning it's attached to 3 other carbons, 1, 2, 3. A quaternary carbon is attached to 4 other carbons. We won't really ever see that, but I mean, in theory, you could have 1, 2, 3, 4, but we're only going to deal with primary, secondary, tertiary. So to assign prefixes like secondary or tertiary, we classify carbon molecules based on if they are primary, or sorry, not primary, if they are secondary or tertiary. Now remember, secondary, I'll go back to my green. We use the number 2 there. It's attached to 2 carbons, and tertiary is attached to 3. And if you guys can remember the second lab where you synthesized tert butyl chloride, this is basically what it looked like the bottom here. The only difference is it had a chlorine group on it. All right. So yeah, tert butyl chloride would look like this. I'll do it a little differently here. Not my best drawing, but we have a tertiary, 1, 2, 3, tert butyl chloride. That's what tert butyl looks like. And I'm going to show you pictures now. So if you're still confused, I have some pictures of these guys so you can kind of get an idea of about what they look like. Okay, so in this course, you're only going to have to look at propyl and butyl. We're not going to go anything beyond that. And again, what I'm saying in this section is a propane or propyl branch, a propyl substituent, can actually form an isomer. It doesn't have to be a straight chain. We can create an isomer like you guys did back in chapter 1. So just because of the number of carbons, propyl is able to form 2 isomers. We have the straight chain normal propyl group, so 1, 2, 3. Something really important to notice, guys, or to know, is that R in chemistry or in our organic chemistry represents like a very, like another carbon chain. So when I say like R and put the group here, I'm saying like this is a group attached to a long carbon chain. So R just represents a carbon chain. Could be anything. So if all three carbons are attached in a line, we call it propyl. Now, I think very early in this course, somebody called it N-propyl. They obviously have done organic chemistry before. I don't mess with the N, I just call it propyl, and IUPAC agrees. Okay, what about if I took the third carbon, for example, and stuck it off the second carbon? I would get this type of shape, okay? And this type of shape we call isopropyl. Well, I guess I don't need to write it, do I? Because it's right here. So iso meaning it's an isomer of the propyl group. There's only one isomer, so we only need one name. So that would be, you guys might have heard of this before. You can get this at the pharmacy. Isopropyl alcohol. So it would look like this with an OH group. It's a good disinfectant. It kills germs. Like, you know, a lot of hand sanitizers have alcohol in them. It might be isopropyl, it might be ethanol, but they're good disinfectants. So again, if you move the point of attachment from a terminal carbon, this is terminal, and you move it to the central atom. So if I take the third carbon I'm circling here and stick it off the second one, this would be isopropyl. Or I guess, sorry, stick it off the first one, I guess I should say. It would be isopropyl. Okay, that's it. So the propyl only has one isomer, and when it's bonded to something, we can call it isopropyl. Now, butane can have a few more isomers. So the butyl group, butyl substituents, we can have, I think, 4 different isomers for butyl. So again, I want you to look at this. We have 1, 2, 3, 4. And think of the isomers we can create with this compound. I can take the end off here. Actually, let me show you in a new slide. White screen. So, okay. Think of a butyl group. So 1, 2, 3. 1, 2, 3, 4. Okay. So remember, R just stands for a long, long carbon chain. It could be a ring. I don't know. It doesn't matter. But just look at this and imagine. Okay. So what if I take the end off? So I have my R. I have 1, 2, 3. And I'm going to take the 4th carbon away, and I'll stick it on the 1st carbon. That's one isomer. Okay, what's another isomer? Well, I could take that last carbon away again. This pen. I could take that last carbon away again. So I'm looking at taking the 4th carbon, and I could put it on the 2nd group. Okay, so these are completely different isomers. Remember, I'm only looking at what's after the red line there. Okay, these are groups on a carbon chain. These are branches or substituents. The last one I can have looks a little weird, but I like the name because it's very easy to memorize. The last one would look like this, where I take 2 groups off. So I would take 3 and 4 away and attach them to the 1st carbon. And I know this one looks weird, but it kind of looks like a T, doesn't it? This is tert. So tert is probably one of the easiest ones to name. And I have pictures of this on the next slide, but this would be just 1, 2, and then I have 2 extra carbons attached to the 1. But every situation here, I have 4 carbons, right? 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So these are isomers of butyl or butane. So let's go look at the name of these. And then after that, I'm pretty much done for today. We might give this a little practice. We'll see. So, okay, this one we know. We just call this butyl. Easy. Now, what happens if we look at the first isomer where we take a carbon from the end, this fourth carbon, and we attach it to the first carbon? If a methyl connects at one of its internal carbons, it's called secondary butyl or sec-butyl. So this methyl here, this carbon is a secondary carbon because it's attached to two others. I guess I should say, well, no, that's right. This carbon is attached to a secondary carbon. So this would be called sec-butyl. Okay, so if a methyl connects to one of the internal carbons, it is secondary butyl or sec-butyl. If the methyl group connects to one of the terminal carbons, it is isobutyl. So notice here the difference is it's not connected to the first one, it's connected to the second one. This is called isobutyl. And the last one is the easiest one because it kind of looks like a T. Now, depending on the computer software that draws it, but when I drew it on the other slide, it kind of looked like a T, right? This would be tert-butyl. And the reason it's called tert-butyl is because it's a tertiary carbon. All right, tert meaning tertiary, attached to three other carbons. All right, that's really it. So you guys kind of just got to memorize that. So 1, 2, 3. Notice I'm not counting the carbon in the chain. I'm only counting the carbons in my substituent. Okay, so let's just do a little recap. If it's a straight chain, so 1, 2, 3, 4, you just call it butyl. If it's attached to an internal carbon, so a carbon inside the molecule, this would be a secondary carbon attached to two others. So we call it sec-butyl, secondary butyl. If it's attached to basically one of the terminal carbons, basically at the end of the chain, this would be called isobutyl. And if it makes like a crazy almost T shape, it's called tert-butyl. And again, that's because this is tertiary. All right, you guys are pretty quiet today. What's that? Okay. All right. So according to IUPAC, isobutyl, sec-butyl, and tert-butyl are allowed to be kept as common names. So the reason you're learning these names is because they are IUPAC, meaning they've been allowed to stick around. In the latest guide, tert-butyl has been kept as the preferred, and the other butyl names have been kind of removed. But that's why in the lab on, what was it? I don't know the date, but the second lab you guys did, that's why we kept it as tert-butyl chloride, because that's the IUPAC name. So to name branched substituents with IUPAC method, so tert-butyl still keeps around, basically treat each branched substituent as its own naming problem. Carbon 1, the first carbon of the branch substituent, is where it meets the main chain. And when you name the substituent, or again, remember when I say substituent, I mean the branch, you put the name in brackets. So let me show you how this works. I'll basically show you two examples, and maybe we'll pick this up next day for a review. Okay. So naming branch substituents using the IUPAC or systematic method, you guys might like this a lot easier. So on a test, I'll take both. So you guys might call this isopropyl, But you could also name this using systematic naming. So let me explain. Let's go through this. So this carbon, I have 1, 2, 3, 4, 5, 6, 7 carbons. On the third carbon, I have a methyl. On the fourth carbon, and I'm actually missing something in my name here. Oops, hold on. Oops, sorry guys, I just had to fix something. I'm almost done, by the way. I'm just going to show you 2 examples and we'll come back to this tomorrow. We might almost finish chapter 2 tomorrow. Okay, so on my third carbon, I have a methyl group. On the fourth carbon, I have this crazy looking group. And I told you that this is technically isopropyl. However, modern IUPAC says if you don't want to call it isopropyl, you can name it systematically, meaning you take this group as its own naming problem. So this is a 2-carbon chain. Now, you always start the chain, you always start counting at the carbon that is attached to my main chain. Okay, so maybe I'll pick a different color than red. Make this a little more sense here. All right, oh, yeah. All right, so the red, guys, is my main carbon chain. You can see it down there, right here. Now, the branch starts at my first carbon that touches the chain, and I'm going to name the longest chain, so that's obviously ethyl or ethane. And on the first carbon, I have a methyl group. So we could call this systematically 1-methyl ethyl. Now, what do you guys think in the chat? What do you like better? Would you rather call it 1-methyl ethyl, or would you rather call it isopropyl? What do you like better? I think everybody's. Yeah, I just. Okay. All right. I got 1 vote for isopropyl. I got, okay, 3 votes for isopropyl. Yeah. So, yeah. So honestly, guys, I'm okay with that. I mean, if you guys want to stick with isopropyl, that is fine by me. The only tip I'll give you is to just kind of memorize these shapes here. So, you know, on slide 45, make sure you know both of those. On slide 46 and 47, make sure you know those. And I'm going to create, maybe the end of today, I'll make a little summary here. That'll probably be my last slide today, slide 52. I'll fill in a little summary here. Okay, let's do one more. And again, guys, I will totally take ISO on a test. And Naim says he's okay with either, which is good too. Like, that's kind of how I feel. I could do either. It kind of depends. You guys might like this one a little better. Okay, so watch this. I'll go back to red. This is my last one. Then we'll take a break. So 1, 2, 3, 4, 5. Okay, sorry, just making sure I'm counting in the right direction. Either way I count this, it's nonane. 9, we haven't really done nonane yet, have we? So it's 9 carbons in a chain. Now, this branch, okay, we just learned that it's 1, 2, 3, 4 carbons. We learned that this would be iso, not sec. Secondary would be if it was bonded here at this carbon. We learned that this was called isobutyl. And I know that because I know the shape, I know the definition. It's when I have the carbon bonded to one of the last carbons in the chain. So this would be called isobutyl. It is definitely not tert-butyl. It is, I could see you getting this mixed up with sec-butyl, but sec-butyl would be if the bond was there, but it's not. So, okay, let's look at this. Let me pick another color, and let's learn how to name this systematically. So, 1. So obviously I take my first carbon, 2, 3. Okay, you could number the other way. On the second carbon, I have a methyl. So this would be, if I name this group together, like if I name this whole thing, it would be, well, this. 2-methylpropyl, meaning on the second carbon, I have a methyl group, and it's 3 carbons total. So I would call it 2, because of, the second carbon here, 2-methylpropyl. So the name of this compound would be 5, and then in brackets, 2-methylpropyl nonane, or you could just call it 5-isobutyl nonane. And I'm okay with whatever you guys want to do on a test. So this is called, again, systematic.
I have a question.
Yes, ask away.
If I write ISO, I don't have to add brackets, right?
Right. Okay, that's a really good question. So the question was, if you choose to do the ISO naming, you don't need brackets. Absolutely. The only reason you need brackets in this type of naming is because we have an extra number in here. So just like in math, to kind of help us organize our numbers, we use brackets. And this is called systematic naming, which is basically IUPAC, but this is okay too. Okay. You know what? I think I'll stop it. I'll stop for today. I will just fill this slide out, and we'll talk more about this tomorrow. This pen just drew isobutyl 1, 2, 3, 4. I'm just going to fill this out for you. Yes?
Did you record the lab?
Nope, not yet.
Sir, do you think I can come and help you at the lab so I don't do it online?
Nope, sorry.
Okay, sir.
All right, no problem. Oops, sorry, I'm just drawing these for you guys. If you have your notes printed, my tert butyl is not very pretty, is it? If you have your notes printed, you can fill these in now, a little study guide for you. This is our butyl groups. This is the systematic name or the IUPAC name. Basically, I'll take anything you want. It seems like the class likes these common names, so you can use the common name, IUPAC, systematic, whatever you want. I don't care, as long as it's right. So if you guys want to pick the common names, you are more than welcome. All right, guys, it's 5 after 10. I'm going to end it there. Next day, I'll do more of a review. I'm going to show you a couple more. And then we're basically done this chapter. The last part of this chapter is very simple. So yeah, there you go. I'm going to hit stop record. And if you guys have any questions, let me know.